In this video, we are going to talk about the Chapter 2B, quiz number 2, go over the answers, and how to score it. So in question number 1, it says, given f of x equals the square root of x minus 6, find the equation of its inverse. Also find the domain of the inverse. So the first thing we're going to do is switch the x and y. So instead of f of x, I'm going to put x, and instead of x, I'm going to put y. And then I'm going to resolve for y. So the first thing I need to do is get rid of this square root. So I'm going to square both sides. So I'll get x squared equals y minus 6. Then I'm going to add 6. So I get x squared plus 6 equals y. So my final answer is that my inverse would be equal to x squared plus 6. Now this first part is worth 4 points. So 4 points would be awarded to a fully correct problem. If you made a computational error in terms of adding, multiplying, things like that, I would take off anywhere from half to 1 point. If there are multiple errors, you would take off multiple of those 4 points. So this first part is worth 4 points. Now we want to determine the domain of the inverse. So to figure out the domain of the inverse, I need to think about the range of the original function. So when I think about this original function, it's a square root that's shifted right 6. So it would still start at y equals 0. So the range of this original function would have been 0 to infinity. So that means the domain of the inverse would be 0 to infinity. This domain is also worth 4 points. If you had incorrect notation in terms of you didn't have a square bracket and a round bracket, or you didn't choose 0, I would take off half a point for notation and 1 point for not having the correct numbers in each spot. All right, in question number 2, it says, given the graph of f to the right, find the domain of the and range of the inverse. Remember, the domain and range of the inverse is just the reverse of the domain and range of the original function. So I'm going to find the domain and range of the original function, and then I'm just going to reverse them. So if I look at this graph, the domain would be from -5 to -1. I would have a square bracket on -5 and a round bracket on -1. Union 2 to, well, it's going right forever, so 2 to infinity. Square bracket on 2, round bracket on infinity. To do the range, it's pointing down, so -infinity to -1. Square bracket, union, starting 1 with an open circle, so a round bracket, to 5 with a square bracket. So now these are representing the domain and range of the inverse. So I'm just going to switch my domain and range. So the domain of the inverse would be the same as the range. And my range of my inverse would be the same as the domain of the original function. So this question was also worth 4 points. So 2 points for the domain, 2 points for the range. I would take off half points if I didn't have the correct numbers in each spot. I would take off half points for each notation, so making sure we have round brackets and square brackets in the correct spots. In number 3, it is talking about a point, 0, 3, and 3, 5. So remember, when it comes to an inverse, if I have a function with the point x comma y, that inverse, the same point would be y comma x. So this says f of 0, meaning that x is 0. So if I look, if x is 0, my output is 3. Now it's saying if the inverse, this should say -1s here. If the inverse is 3, this is saying y is 3. That means this would be 0. F of 3 would be -5. F of the inverse of -5, well, that would be the output y, so it's looking for x, so this would be 3. If 3, 4 is on the graph of an even function, what other point would be on the graph? So even functions have symmetry with are symmetric with the y-axis. So if I think about this point is at 3, -4, And I was thinking about symmetry, it would move to over here. So it would move to -3, -4. Number 5 asks you to algebraically determine if this function was even, odd, or neither. So if I have f of x equals 6x minus x to the third, to determine if something is even or odd, I would put -x in for x. So everywhere where there's an x, I'm going to replace it with a -x and then simplify. So I would get -6x plus x to the third. So if a function is even, when you put in -x, you're just going to get the regular function back. If a function's odd, you get something equivalent to the opposite of that function. So if I think about negative f of x, that means it'd be the opposite of 6x minus x cubed. So it ended up being -6x plus x to the third, which is what I've got here. So this would be an odd function. Then it says, based on your answer above, what kind of symmetry does it have? Well, if it's odd, it has symmetry with the origin. All right, in 6, it says, use the function to determine the rate of change below. So if I'm doing rate of change, I'm going to do f of 6 minus f of 2 all over 6 minus 2. So I need to find out what is the y for 2 and what is the y for 6. So if I substitute in 2, I would get 31. And if I substitute in 6, I would get 2,579. All right, so now I'm going to have 2,579 minus 31 all over 6 minus 2. So 2,548 over 4, which will give me 637 as my average rate of change. Now, when we're finding the instantaneous rate of change at a specific point, we're going to use negative 3.00 as our second x value. So I'm going to find f of negative 3.001 minus f of negative 3 all over negative 3.001 minus negative 3. So at negative 3, my y is 176, and at negative 3.001, my y is 176.219. So I'm going to have 176.219 minus 176 all over negative 3.001 minus a negative 3. So when I do that computation, I'm going to get negative 219 as my instantaneous rate of change at negative 3. All right, the second part says, now we want to find the difference quotient for f of x equals 4x squared minus 3x plus 2. So my difference quotient formula is f of x plus h minus f of x all over h. So the first thing I want to find is f of x plus h, which would equal 4 times x plus h squared minus 3 times x plus h plus 2. So if I'm squaring this, I'm going to get x squared plus 2xh plus h. Remember, you are technically doing x plus h times x plus h, so if you need to multiply that out by hand, feel free. Distribute the negative 3. So for f of x plus h, I'm going to have 4x squared plus 8xh plus, this would be h squared, plus 4h squared minus 3x minus 3h plus 2, minus f of x, so minus 4x squared minus 3x plus 2 all over h. So when I subtract everything after the subtraction sign, all this first part's going to stay the same. Then I'll have minus 4x squared plus 3x minus 2. So my 4x squared will cancel with my negative 4x squared. My negative 3x will subtract with my 3x, and my 2 will subtract with my negative 2. So I'll be left with 8xh plus 4h squared minus 3h all over h. So my final answer will be 8x plus 4h minus 3. So now, using the difference quotient to calculate the average rate of change. So I'm going to use this difference quotient that I just found. And I'm going to calculate the average rate of change. So I'm going to use the smaller x value, and then my h value is the distance between my x values, so it's going to be 10. So I'm going to have 8 times negative 3 plus 4 times 10 minus 3. So I'd have negative 24 plus 40 minus 3, which would equal 13. Now they want us to use the difference quotient to calculate the instantaneous rate of change. So anytime you're talking about instantaneous rate of change, that means your h is 0.001, and I'm going to use my x as 4. So 8 times 4 plus 4 times 0.001 minus 3 equals 29.004. So either 29.004, or if you just round to 29, that's okay too. So on this page, this first one is worth 4 points. So again, algebraically, you should be showing that it is odd. So if you got up to this answer, that'd be worth 2 points. But then understanding that it's odd is another 2 points. The second point question is 2 points. So if you thought that this was even and you put y-axis here, then you could have 1 point for this. If you said it was odd, though, you want to make sure you have origin here. In number 6, each of these parts were worth 4 points. So again, 4 points for correct, 3 points for minor error, 2 points for multiple errors taken off. Only 1 point if you weren't sure how to do this problem and you just tried something mathematically. Same with B. 7 is worth 4 points. There's a lot of computation there. So again, half point off for a minor computation error, a whole point off for a major computation error, and so on and so forth. Each of these were also worth 4 points. So again, look at your computation. Half point off for a minor computation error, a full point off for a major computation error.